Hello. Hello guys, am I audible? So last, yes, I think it's perfect. Yes. Yes, it's perfect only. Let me check the sound also. Let me check the sound also. It's perfect only. Yes. Yeah guys, hello. Hello. Arya, yes. So we can start the session anyway. If it is perfect, we can start the session guys. So already we finished part 1. So we are moving to part 2. VSEPR Theory. Last I gave you one question. Finished. Yes. Limitation of octet rule that we already discussed. Limitation of octet rule that we already discussed, and I give you one question. Okay, so the question was this one. So example of super octet molecule. So you can write the answer. You can write the answer. So come on. So Arya, yes. Live chat. So everyone quickly mark your attendance. Everyone quickly mark your attendance. Okay. So we can start. So what is actually super octet molecule? What is super octet molecule means? Super octet molecule means the central atom should contain more than 8 electron. Okay, that is super octet. Okay, so more than 8 electron we can check SF6. Okay, how you will check SF6? Yes, SF6. So when you consider SF6, what is the atomic number of sulfur? It is 16. Okay, so I am writing 16. So outermost shell contains 6 electron. Okay, outermost shell. So I am writing just outermost electron. Okay, outermost shell contains 6 electron, and the sulfur is bonded with 6 other fluorine. Okay, so it's a covalent bond. Okay, it's a covalent bond. So what is covalent bond means? It's mutual sharing of electron. Okay, here you can see mutual sharing of electron. So that means sulfur will give 1 electron to share. Okay, and fluorine will also give 1 electron to share. Okay, so 1 electron share. So you will get, so here we know that 6 fluorine is there. So 1 fluorine will give 1 electron to share. So fluorine will give 1 electron. Okay, so fluorine will give 1 electron and sulfur will, so here you can see 6 fluorine is there. So 6 fluorine will give 6 electron to sulfur to share. Okay, fluorine will also give 6 electrons. So that means sulfur will also give 6 electron to fluorine. So it's a mutual sharing. Okay, so that means sulfur will get another 6 electron from fluorine. So now total 12 electrons are there. Okay, now total 12 electrons are there. So total 12 electrons are there means it is more than 8 electrons. Okay, sulfur, the outermost shell of sulfur contain more than 8 electrons. Then we can consider PCl5. So when you consider PCl5, it is phosphorus. Phosphorus contain outermost shell as 5 electron. Okay, phosphorus contain 5 electron in the outermost shell. So when you consider chlorine, this phosphorus is bonded with 5 other chlorine through covalent bond. So that means phosphorus will give 1 electron to share, chlorine will give also 1 electron to share, mutual sharing, covalent bond. Okay, so here also, here you can see 5 chlorine is there. That means 5 electron will give to phosphorus. Okay, so 5 total 10 electrons. Okay, 10 electrons. Okay, total outermost phosphorus contain 10 electron in the outermost shell. Okay, so this is also not possible. This is also follow super octet. This is actually super octet molecule. Then we can write easily, yes, all of the above. Okay, you can write easily all of the above. So when you consider iodine also, IF we can consider. Okay, we can write. Okay, so when you consider iodine, okay, IF4, okay, not IF4, it is IF7. Yes, IF7. So we know that iodine contain 7 electron in the outermost shell. Okay, iodine contains 7 electron in the outermost shell. So I am writing 7 electron already is there. So, and fluorine, 7 fluorine is giving 1 electron to iodine to share. Okay, so total 14 electron. Oh my god, 14 electron. So it's also more than 8 electron in the outermost shell. So we can consider all of these. So correct answer is all of these. Then I will give you another question. You can write the answer. Come on, so tell me what is the correct answer. The octet rule is not obeyed in. So what is octet rule? So the outermost shell should contain 8 electron. Okay, only 8 electron. Okay, so more than 8 means it is actually limitation of octet rule, and less than 8 electron means that is also limitation of octet rule. So here you can see the octet rule is not obeyed in. So we can consider CO2. So CO2 is there, BCl3 is there, and 1 and 2 PCl5. So we already discussed PCl3. PCl3 will not obey octet rule. Okay, will not obey octet rule. When you consider BCl3, okay, so easily we can consider BCl3. So hydrogen, helium, lithium, beryllium, boron. So Cl. Okay, so here boron contain 3 electron in the outermost shell. Okay, so 1 boron contains 3 electron in the outermost shell, and boron is bonded with 3 other chlorine. So chlorine will give 1 electron each. Okay, so that means 3 electrons from chlorine also. So total 6 electron. So 6 electron means it is less than 8. Okay, less than 8. So it is also not obey octet rule. So then what is the correct answer? Correct answer is option 4. Okay, option 4 is the correct answer. Okay, then we can move to next question. So odd electron, we already discussed odd number of electron. So an odd electron molecule among the following is, come on. Come on, so tell me what is the correct answer? Odd electron. Which element or which molecule will follow odd electron stability or odd electron molecule? Which molecule is actually odd electron molecule? So that is NO and NO2. Okay, already we discussed. Okay, when you consider NO and NO2, so it contains odd number of electrons, so it is more stable. Okay, so it is actually 2015 NEET question. Okay, it is 2015 NEET question. Then we are moving to another question. No, we are moving to next topic, that is Lewis representation of symbol molecule. So how we already discussed Lewis representation and all. So this charged molecules are there. Charged molecules means sometimes minus is there. So you can represent using 2 minus, yes, 2 minus, minus, plus, okay, with electrons. Okay, we are just, that is 𝐤𝐤. Okay, what is 𝐤𝐤? Nucleus and, okay, nucleus and inner shell electrons. Okay, that is 𝐤𝐤. So this is actually 𝐤𝐤 form. Okay, if you are writing fluorine means that is 𝐤𝐤. Okay, so and you can write the charge also. Okay, you can write the charge also. Then we are moving to next topic, VSEPR theory. Okay, we are moving to next topic, VSEPR theory. So after that, after this class, I will share this PPT. Okay, if you want, you can do the question. Okay, you can do this PPT contain lots of questions. So if you want, you can do the questions. Okay, so VSEPR theory and shape of molecules. Okay, what is VSEPR theory? So VSEPR theory means it is based on shape of molecule. Okay, it is based on shape of molecule. Okay, so what is the full form of VSEPR theory? What is the full form of VSEPR theory? Valence shell electron pair repulsion theory. Okay, valence shell electron pair repulsion theory, that is VSEPR theory. So when you consider a structure of a molecule, okay, when you consider a structure of a molecule, that I'm considering BCl3. Okay, BCl3. So the structure of a molecule is depend on the central atom. Okay, who is the central atom here? In BCl3, B is central atom. Okay, B is central atom. So structure of a molecule is depend on central atoms, the outermost electron in the central atom. Okay, outermost electron in the central atom. Okay, so this outermost electron contain bond pair, lone pair. Okay, so I will tell you what is bond pair and lone pair in detail. Okay, so first point, we can move to our first point. This VSEPR theory was developed early by Sidgwick and Powell. After that, some scientists. Okay, so some scientists, that scientist has Gillespie and Nyholm. Okay, Nyholm is improved the theory. Okay, they improved the theory further. Okay, so the first point of VSEPR theory. Now we are like following new VSEPR theory or improved version of VSEPR theory. Okay, so the geometry and shape of a molecule. So when you consider, so I will tell you what is geometry and shape. Okay, geometry is different, shape is different. Okay, so the geometry and shape of the molecule depends upon the number of electrons. Okay, geometry and shape of molecule depend upon the, just a second, depend upon the number of electron pair. Okay, so the geometry and shape of the molecule depend upon the number of electron pair. So bonded, we know that bonded pair is there and unbonded pair is there. So that unbonded or non-bonded pair we will call lone pair. Bonded pair is bond pair and non-bonded pair is lone pair. Okay, so the geometry and shape of the molecule is depend on the geometry and shape of the molecule depend upon the number of electrons present in or number of electron pairs in valence shell of the central atom. Okay, so here we know that B is, okay, B is the central atom. Okay, boron is the central atom, and how many electrons are there, or how many valence electrons are there in boron? So we know that atomic number is 5. Okay, hydrogen, helium, lithium, beryllium, boron. Atomic number is 5. So electronic configuration is 2, 3. Okay, so out 3 electrons, this boron contains 3 electrons in the outermost shell. Okay, boron contains 3 electrons in the outermost shell. So when you consider this BCl3, the structure of BCl3 is depend on boron. Okay, it's depend on boron's outermost electron. Okay, boron's outermost electron. Okay. Okay, I hope it's clear. Then you can watch, no issue. If you want, you can watch. Okay, so that is the first point. Then second point is the electron pairs surrounding the central atom repel. Obviously, it will repel. We know that everything is electron. Okay, outermost layer you can see electrons only. Okay, what is the charge of electron? Charge of electron is negative. So negative means like charges will repel. Okay, like charges will repel. The electron pairs surrounding the central atom repel one another. Okay, so central atom you can see, obviously not only in central atom. So we know that it is electrons, so electrons will repel each other. Okay, so the electron pair surrounded by the central atom repel one another as their orbital or electron cloud are negatively charged. Because they are like charge means obviously it will repel each other. Okay, like charges means it will repel each other. Then we are moving to next point. In order to minimize the repulsion, what we can do to minimize the repulsion? Congrats. Neither your college join Pannirva ma'am. My score is 572. Very good, Surya. Congratulations. So where are you from, Surya? So 572 means you will get, you will get good college. Government college you will get. Definitely you will get government college. No worries. Okay. So in order to minimize the repulsion, okay, in order to minimize the repulsion, these electron pairs tend to occupy such position in space where the distance between them is maximum. Okay, so how we can minimize the repulsion? There is only one way to minimize repulsion. So maximum distance. Okay, so you can keep maximum distance. Okay, you can keep maximum distance to minimize repulsion. So you can keep maximum repulsion. Same here also. In order to minimize the repulsion, these electron pairs tend to occupy such a position in space where the distance between them should be maximum. Okay, maximum. You can see if maximum distance means repulsion will reduces. Okay, how we can reduce the repulsion? Stay away. Okay, so make a proper distance. Okay, so next point, multiple bond is treated as it is a single electron pair. So we know that triple bond, double bond. So that we will consider as a single electron pair. Okay, we will consider multiple bond as a single electron pair, and the 2 or 3 electron pair of multiple bond are treated as single super pair. So when you consider 2 or 3 electron pairs are there. Okay, 2 or 3 electron pairs are there of a multiple bond. Okay, so 2 or 3 double bond or triple bond is there means we can consider as a single super pair. Okay, single super pair. Next point, the repulsive interaction between two lone pair. Okay, two lone pair are different from one pair. We know that bond pair is there, lone pair is there. So when you consider PCl3, okay, assume that PCl3. So when you consider PCl3, I will show the structure of PCl3. Okay, it's not correct structure. I am just drawing the normal structure. Okay, this Cl, Cl, Cl. So how many electrons are there in PCl3? So when you consider what is the atomic, what is the atomic number of phosphorus? What is the atomic number of phosphorus? What is the atomic number of phosphorus? So we know that atomic number of phosphorus is 15. So when you consider 2 lone pair should be there, okay, not 2 lone pair, 1 lone pair should be there. That means outermost phosphorus, the outermost shell contain 5 electron. When you consider phosphorus, outermost shell contain 5 electron, and this in this 5 electron, which one is my studio? My name is Aswathi. Yeah. Studio 1. So you can use studio 1. Okay. Thank you. Sorry. It's okay. So when you have class, so till you have class till 4:30. 4:30. Ah, okay. Then you can manage. Thank you so much. Okay. So here you can see when you consider phosphorus contain 5 electron in the outermost shell. So from that 5 electron, so here you can see it is mutual sharing, covalent bond, okay, it is covalent bond, so it's mutual sharing. So here phosphorus is bonded with 3 chlorine, okay, so 3 chlorine means this is the electrons, okay. This is the phosphorus electron. So here I am, so phosphorus containing 5 electron in the outermost shell. From this 5 electron, it will make 3 electron will make bond pair, okay, from this 5 electron, from this 5 valence electron, 3 electrons will make bond pair, okay, 3 electrons will make bond pair, and here rest 2 electrons are there, okay, they are not making any bond pair. So this electron pair is called lone pair, okay. This electron, non-bonded electrons are known as lone pair, okay. Non-bonded electrons are known as lone pair, and bonding electron pairs are known as bond pair, okay. I hope it's clear. Now how many bond pairs are there? This is 1, this is 2, and this is 3. So you can write bond pair is 3 and lone pair is 1, okay, because 1 electron is there, means 1 pair is there, okay, that is bond pair, lone pair, pair means 2, 2, okay. So the repulsive interaction between 2 lone pair are different from those between 2 bond pair or those between a lone pair and bond pair. So when you consider, so normally we will think, yeah, it is everything is electron only. So the repulsion is same for bond pair, lone pair and all. No, the repulsion is different for lone pair and bond pair. Okay, the repulsion is different for bond pair and lone pair. So here you can see maximum repulsion you can see in maximum repulsion you can see where you can see maximum repulsion at lone pair, in between lone pair, maximum repulsion. Then lone pair, bond pair, then bond pair, then bond pair, bond pair. So here in bond pair, the repulsion is very less. Okay, the repulsion is very less in bond pair. Okay, repulsion is very less in bond pair as compared to the repulsion of lone pair. This is the order. Okay, this is the order of repulsion. This is the order of repulsion. Then we are moving to next. I will tell you what is geometry and what is shape. Okay, what is geometry and what is shape. What is geometry and what is shape? So here we can draw the molecular structure or the structure of atom or structure of molecule two different ways. Okay, two different ways, including lone pair and bond pair and excluding lone pair. Okay, so geometry or electron pair geometry is predicted using lone pair and bond pair. Okay, so this is the structure of a molecule including lone pair and bond pair. Okay, this is the structure of a molecule including lone pair and bond pair of atom. So when you consider shape, what is shape? Shape means here we will consider bond pair only. So we will consider bond pair only, then we will draw the structure. Okay, we will consider bond pair, then we will draw the structure. That is shape and geometry. I hope it's clear. Shape and geometry clear. Is it clear, guys? I hope it's clear. Then I will give you one question. This is the question, yeah. Try this. Yes. So what is the correct answer, Ada? I can see 3 and 4. Okay, let me check. In CLF, the lone pair occupy equatorial position to minimize. So to minimize obviously repulsion. Okay, so maximum distance means less repulsion. So what will be the correct answer? Lone pair, repulsion only. Lone pair, repulsion, and lone pair, bond pair, repulsion. So when you consider CLF3 contain obviously lone pair is there, bond pair is there. So correct answer is lone pair, repulsion, and lone pair, bond pair, repulsion. Correct answer is 3. Correct answer is 3. Okay. So next, so I will give you just a second, Dada. So I will come. So 5 minutes break. Okay. 5 minutes break. So just a second, I want to, oh yeah, I will come. Okay, so guys, next is how we will draw the structure. Okay, so we know that there's a proper structure for molecule, so how we will draw? So that and I will tell you the structure, geometry, shape and of molecule, okay, of a molecule. So what is EP? EP means bond pair plus lone pair, okay, that is EP, bond pair plus lone pair. So EP is BP plus LP. So just a second, I will tell you how to calculate bond pair and lone pair. Before that, we can do one example, okay. When you consider PCl3, so how we know that phosphorus is the central atom, okay, phosphorus is the central atom. Just a second. So phosphorus is the central atom. So we should calculate first the outermost electron. Okay, first we should calculate the outermost electron of central atom. So how many outermost electrons are there? We know that the atomic number of phosphorus is 15. So 5, 2, 8, 5. Okay, 5 is the central. That means 5 is the valence electron. So I am writing 5. Okay, so phosphorus contain 5 electron in the outermost shell. So here you can see phosphorus is bonded with 3 other chlorine atom. Sorry. Okay, phosphorus is bonded with 3 other chlorine atom. So that means phosphorus is getting 3 other atom. Okay, so I am just writing. So this here you can see. Here you can see. From 5 atom, okay, from 5 valence electron, phosphorus is bonded with 3 chlorine. So chlorine, chlorine, chlorine. So 1 atom, okay. So 1 atom of phosphorus is bonded with 1 chlorine. Another electron of phosphorus is bonded with another chlorine. 1 electron of phosphorus is bonded with another chlorine. So here you can see 3 electron of phosphorus is bonded with the chlorine. Okay, 3 electron of phosphorus is bonded with chlorine. So here you can see bond pair is 3 because phosphorus is bonded with 3 chlorine. Simply you can just check phosphorus is bonded with how many atoms. So phosphorus is bonded with 3 chlorine. So you can write bond pair is 3. So what is lone pair? So lone pair means non-bonding atom. So we know that we will consider pair. Okay, we know that non-bonding atom is actually 2 non-bonded atoms are there, but we will consider pair, that is lone pair. So lone pair is 1. Okay, so here next. So what is EP? EP means bond pair plus lone pair. So when you consider bond pair plus lone pair is 2. Okay, bond pair plus lone pair is 2. Bond pair is 2. Lone pair is 0. Okay, lone pair, there is different conditions. Okay, there is different cases. Okay, so first case is bond pair is 2 and lone pair is 0. So the shape and geometry is same. If lone pair is 0 means the shape and geometry is same. Okay, so what is the shape and what is the geometry? Shape and geometry is linear. Okay, shape and geometry is linear here. Next, here you can see next EP is 3. Okay, EP is 3. So when you consider EP is 3, there is 2 different cases. Okay, in first case bond pair is 3 and lone pair is 0. Bond pair is 3 and lone pair is 0. Just a second. Bond pair is 3 and lone pair is 0. So lone pair is 0 means the shape and the geometry is same. Okay, shape and geometry is same. So here you can see it is trigonal, planar, trigonal, planar. I will draw the structure. Okay, I will draw the structure properly, don't worry. So next is bond pair is 2 and lone pair is 1. Okay, bond pair is 2 and lone pair is 1. So then what will happen? It is actually bend shape. Okay, it is actually bend shape. So bend shape means the geometry is same only. If EP is 3 means always geometry is same. Okay, always geometry is same for EP3. So when you consider EP4, what is EP means? Electron pair. Okay, electron pair is 4 means always geometry is tetrahedral. Electron pair 5 means always geometry is trigonal bipyramidal. When you consider EP, that means electron pair is 6 means always octahedral, and electron pair 7 means it is always pentagonal bipyramidal. Okay, that geometry is similar for same EP. For same EP, what is geometry is same. Okay, so lone pair, if lone pair is changing or lone pair is changing means the shape will change. Okay, only shape will change. So here you can see, when you consider electron pair 3, so electron pair 3 have 2 different cases. Okay, when you consider here, you can see 2 different cases are there. One is bond pair is 3 and lone pair is 0. Okay, bond pair is 3 and lone pair is 0. And shape is trigonal planar. Okay, shape is trigonal planar and geometry is trigonal planar. Why? Because lone pair is 0. Okay, lone pair is 0. Next, bond pair is 2. Okay, bond pair is 2 and lone pair is 1. Okay, bond pair is 2 and lone pair is 1. The shape is bend shape. Okay, shape is bend shape and geometry is same only because EP is electron pair is 3. So that is trigonal planar. Next is EP is 4. What is EP is 4 means? Electron pair is 4. Okay, so when you consider electron pair is 4 means there is 3 different case. Okay, there are 3 different case. First case is 4 bond pair, 0 lone pair. Second case is 3 bond pair, 1 lone pair. And third case is 2 lone pair, 2 bond pair. Okay, so first case is 4 bond pair and 0 lone pair. So the shape and geometry is same. So the shape and geometry is same. That is tetrahedral. Okay, that is tetrahedral. Next is 3 and 1. Okay, 3 and 1. 3 is bond pair and 1 is lone pair. Okay, that is trigonal bipyramidal. Okay, the shape is different. Okay, shape is different. That is trigonal bipyramidal and geometry is tetrahedral. Okay, geometry is same tetrahedral. There is no change because EP is 4 only. Next is bond pair and lone pair is 2, 2. Okay, 2, 2. Geometry is same tetrahedral, but the shape is bend shape. Okay, the shape is bend shape. Next is EP is 5. So when you consider EP is 5, there are 4 different cases. Okay, there are 4 different cases. First one is 5, 0. That means 5 bond pairs are there, 0 lone pairs are there. So that is trigonal bipyramidal. Okay, trigonal bipyramidal. Trigonal bipyramidal. So same da, there is no difference in geometry. Geometry is always same for same electron pair. Okay, so next is 4. 4 is bond pair and 1 is lone pair. So here you can see seesaw. Okay, the shape is actually seesaw. You know guys, seesaw you can see in parks. Okay, seesaw. So next is 3 bond pair, 2 lone pair. The shape is T shape. Okay, this is T, you know, T shape. Okay, T shape. And 2 bond pair and 3 lone pair. 2 bond pair and 3 lone pair means the shape is actually 2 lone pair. Yes, only we will not consider this lone pair. Okay, we will not consider this lone pair. Then 2 bond pair means it is linear only. Okay, it is linear only. 2 bond pair means it is linear only. Then we are moving to next type. Okay, next type is 6. Okay, bond pair is 6, not bond pair, electron pair is 6. So when you consider electron pair, 6 electron pair means it is actually, it contains 3 different cases. Okay, one is 6 means bond pair is 6 and lone pair is 0, that is octahedral, so that geometry is also octahedral. Next case is 4 bond pairs, okay, 4 bond pair and 5 bond pair, okay, 1 lone pair, 2 lone pair case. So 5 bond pair means, we know that 5 bond pair means there is 1 lone pair should be there, okay. So lone pair plus bond pair is actually 6. So 5 plus 1, you will get 6, okay. And 5 bond pair, 1 lone pair, the geometry is similar only, octahedral, but the shape is square pyramidal, okay. And next is 4 bond pair, 2 lone pair. 4 bond pair means that is square planar, okay. The shape is square planar and geometry is same octahedral. Next is 7. 7 we have 2 different cases. One is 7 0. 7 0 means 7 bond pair, 0 lone pair. So that is pentagonal bipyramidal. So the shape and geometry is similar only, pentagonal bipyramidal. Next is 6 1. 6 1 means that is distorted octahedral, okay, that is distorted octahedral. So the geometry is similar only, pentagonal bipyramidal. So we can do examples, okay, we can do the types, okay, we are drawing all the structures and all, okay, we are just drawing the structures of all molecules. Okay, come on. Okay, so type, this is type 2, type 1, yeah, this is type 1. So I will write this is AB type, okay, AB type. What is AB type, bada? So AB type means AB type, AB2 type, not AB type, AB2 type. So A is a central atom and B is a bonded pairs or bonded atoms, okay. A is a central atom and B is the bonded atoms. So here this is the structure. So we know that BB. So what is the bond angle? Obviously it is 180 degree, okay, 180 degree. So bond angle and the bond pair, and we can write bond pair lone pair, okay, we can write, I am writing bond pair is equal to, how many bond pairs are there? 2 bond pairs are there, okay, 2 bond is there now, so bond pair is 2. So is there any lone pair? Is there any lone pair? There is no lone pair, only bond pair. So bond lone pair is 0. So lone pair is 0. Next, so I'm writing the shape and geometry. it's perfect now. Now I think this audio is perfect. Hello? Yes. Now I think it's perfect. Okay. So yeah, we can start. So the bond angle is 120 degree and here A, B, B, B. So that means bond pair is 3 here. Okay, bond pair is 3 here. There is no lone pair. Okay, there is no lone pair. Bond pair is 3 here. Okay, yeah. So here next we are moving to next type. This is, that means here you can see here EP is actually, EP, that means electron pair is actually 3. Okay, electron pair is actually 3. Then next type is same, EP is 3 only, EP is 3 only, but you can see 1 lone pair and 2 bond pair. So here I will draw the structure A. So this type normally we will say A, B2E type. Okay, A, B2E type. This is A and this is lone pair. So this is bond pair. Okay, so bond pair is 2, lone pair is 1 and EP is 3. Okay, EP is 3. I hope it's clear. Okay, so here BP 2, LP 1 and EP 3. So this is the and what is the geometry and shape? Tell me what is the geometry and shape. So here I forgot to write the geometry and shape here. So tell me here what is the geometry and shape? Geometry and shape is similar only. Why? Because there is no lone pair. Okay, why? Because there is no lone pair. So what is geometry and shape? Geometry and shape is trigonal planar. Okay, trigonal planar. Okay, so if here you can see 1 lone pair is there, 2 bond pair. So just ignore that lone pair. Okay, ignore the lone pair, then you will get a shape. Okay, just ignore this lone pair, then what is the shape? So here I am writing geometry. Geometry is similar, trigonal planar. Trigonal planar. Okay, what is the shape? Shape is there. Okay, why? Because here the shape is different. Why? Because here lone pair is present. So lone pair is present means shape is different. So tell me what is the shape? Shape and geometry is different. So what is the shape? It is, here you can see, we can ignore this. Okay, we can ignore this lone pair. Okay, if you are ignoring this lone pair, you will get this type of shape. Okay, this is a bend shape. Okay, this is a bend shape. Okay, so the shape is actually bend shape. Then next type AB4 type. Okay, AB4 type. So there is no lone pair, only bond pairs. Okay, there is no lone pair. First case is there is no lone pair. We are only considering bond pairs. So bond pair is 4 and EP is also 4 and lone pair is 0. Okay. So what is the structure? So the structure I will draw. Okay, B, 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 B. And here the structure and the geometry and shape is similar. Why? Because there is no lone pair. Okay, the shape and geometry is same. Geometry and shape is same. Shape is same. That is tetrahedral. Okay, tetra. So 4 is there. Tetrahedral. So here I am writing tetrahedral. tetrahedral. Okay, is it clear? I hope it's clear. Then we are moving to next type. So, and guys, here the bond angle is also very important. 109 degree 28 minutes is the bond angle. Okay, so next type is same. Okay, here the EP is, that means electron pair is 4 only, but lone pair is present. Okay, so the first shape is AB3E type. Okay, AB3E type. So I will draw A. So one is lone pair. Okay, so A. So what is the structure? What is the structure? So here the shape A, B, sorry, here it is B. Okay, B, and lone pair is 1, bond pair is 3, and next point is the shape and geometry. So I am writing shape. Already we know the geometry. What is, so EP is 4 means, here I am writing EP is 4 means, we know that EP is 4 means tetrahedral. Okay, so always it is tetrahedral. If it is EP is 4 means tetrahedral. Then what is the shape? So I will write geometry and shape. Okay, geometry, tetrahedral. And what is the shape? What is the shape? So you can ignore this lone pair. Okay, you can ignore this lone pair. So you will get a structure. So that structure is actually trigonal pyramidal. Okay, so that is trigonal pyramidal. Okay, next type is, okay, then we are moving to next type, that is AB3E, no, AB2E2 type. Okay, AB2E2 type. AB2E2 type means, so A, so this is also lone pair, this is also lone pair, so this is the bond pairs. Okay, so here the geometry is similar, so I am writing shape only. What is the shape? So if you are ignoring this two lone pair means you will get bend shape. Okay, so shape is bend shape. Bend shape. Okay, shape is bend shape. Okay, then what? Shape is bend shape. Bond pair and lone pair. Lone pair is equal to 1. No, lone pair is equal to 2. Bond pair is equal to 2. So geometry is tetrahedral. Okay, geometry is tetrahedral. Okay, then we can move to next type. Okay, next type is AB5 type. Okay, AB5 type. So I am writing here AB5 type. Okay, AB5 type. So in AB5 type, so first we are considering there is no lone pair, only bond pairs are there. So I will draw the structure A, B, 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 B. Okay, so bond pair is 5, and so here I am writing bond pair is 5 and lone pair is 0. So here we can write the geometry and shape. So geometry and shape is similar only. Why? Because there is no lone pair. So I am writing geometry and shape. Geometry and shape is actually, how much is geometry? What is geometry and shape? The geometry and shape is actually, here you can see triangle is there. Okay, and 2 pyramid is there. Okay, so 2 pyramid up and down, you can see 2 pyramid also. So trigonal bipyramidal. Trigonal bipyramidal. Bipyramidal. Trigonal bipyramidal. So trigonal bipyramidal. And just what is the bond angle, guys? What is the bond angle? So here you can see two bond angle. One is 90 degree, another one is 120 degree. Yes, 120 degree bond angle and 90 degree bond angle. Okay, here you can see two bond angles. Okay, here you can see two bond angles, and here trigonal, the geometry and shape is trigonal planar. Next, here you can see bond pair is 2 and lone pair is 1. Bond pair is 2, lone pair is 1. So here I am writing bond pair is 4, sorry, bond pair A, B 4, lone pair is 1, E, A, B 4, E. What is A, B 4, E means? Lone pair is 1 and bond pair is 4. So what is the structure? The structure is actually A, this and okay. This is the structure of this molecule. So here I am writing bond pair is 5 and lone pair is 1. Okay, lone pair is 1. So here I am writing J channel, that soon. So next here I am writing what is shape and geometry. First we can write a geometry and shape. What is the geometry, guys? What is the geometry? What is the geometry? So trigonal bipyramidal. So already we discussed trigonal bipyramidal. So trigonal by triangle, it's look like it's look like triangle and two pyramids are there. Okay, soon. So here trigonal bipyramidal. So trigonal bipyramidal. So here you can see, guys. So guys, inga enna irukku? So you can see here one lone pair is there. So we can ignore the lone pair. Then you can see a seesaw shape. You know what is seesaw? You can see seesaws in parks. Okay. So that seesaw shape. Okay. So shape is actually seesaw shape. Okay. Seesaw shape. Okay. Seesaw shape. Lone pair, bond pair. I think everything is clear. So then we are moving to next type. 3 bond pair, 2 lone pair. Okay. 3 bond pair and 2 lone pair. So that is A. 3 bond pair means AB3E2 type. Okay. So here this is A. So guys, so bond pair is equal to 3, lone pair is equal to 2. Okay. So what is here I am going to write the shape and geometry. So tell me what is geometry? What is geometry? Geometry is trigonal bipyramidal. Pyramidal, trigonal bipyramidal. And what is the shape? What is the shape? I am writing the shape here. What is the shape? Shape, just ignore this lone pair. Then you will get a shape that is T shape. Okay. It's look like T. So you can write T shape. T shape. Then we are moving to next type. Next type is 2 bond pair and 3 lone pair. Okay, 2 bond pair, and so that is A 2 bond pair and 3 lone pair, A B 2 E 3. So A, so I will draw structure. Okay, so it is actually linear shape. Okay, linear shape. So it is BB. So shape is actually linear. And what is the geometry? We are recalling the geometry. Okay. Hi Shreya. Geometry is what? Geometry is, I'm thinking, trigonal bipyramidal. Then what is the shape? Shape is what is the shape? Shape is actually, this is linear. You can ignore the bond lone pair, then you will get linear shape. So here I am writing bond pair is equal to 2 and lone pair is equal to 3 and EP is equal to 5. I hope it's clear. Then we are moving to next shape, that is type 5, that is AB6. Okay, AB6 type. So what is AB6? So this is the structure. Okay, so it's look like, it's normally we will say it's octahedral. Okay, octahedral. And bond angle, you can see two different type of bond angle. One is 90 degree, 180 degree, another one is 90 degree. Okay, 90 degree also. So there is two different type of bond angles, 90 degree and 180 degree. This is B. So here I am writing bond pair is 6 and lone pair is 0. EP is equal to bond pair plus lone pair, you will get 6. So what is geometry and shape? What is geometry and shape? So I am writing here geometry and shape. Geometry and shape is octahedral. Okay, octahedral. Octahedral. So next we are moving to 5 bond pair and 1 lone pair. Okay, 5 bond pair and 1 lone pair. So that is square pyramidal. Okay, square pyramidal. So here I am writing A B5 E. A B5 E. There is 1 lone pair. So here I am writing bond pair is 5, lone pair is 1 and EP is equal to 6. So next is A B E type. Yes, E, yeah, 1 pair will go. 1 2 3 4 Okay, so one lone pair is there and 5 bond pairs are there. So tell me guys, what is the shape? This is octahedral geometry. So I am writing geometry is octahedral. Geometry is octahedral. What is the shape? What is the shape? What is the shape? Shape is actually, tell me what is the shape, Ada? Shape is one, yes, what is the shape? If you are ignoring that lone pair, you will get a square with a pyramid. Okay, so square pyramid. So square pyramidal. Okay, then we are moving to 4 bond pair with the 2 lone pair. So here I am writing. Square pyramidal, and this is A B4E2 type. A B4E2 type. Bond pair is 4. Lone pair is 2. So A 1 2 3 4 and 2 lone pair. So it's square. Okay, it's square in one plane, so it's square planar. Square in one plane, it's square planar. Geometry is octahedral. Geometry and shape is, what is shape? Shape is planar, square planar. Square planar. Then next is type 6. Okay, type 6 is actually 7 bond pair, 0 lone pair. Okay, 7 bond pair and 0 lone pair. So 7 bond pair and lone pair. So here you can see this is the structure. So this structure is important. So 7 bond pair and 0 lone pair, pentagonal bipyramidal and distorted octahedral. 6 bond pair and 1 lone pair. Okay. So guys, this is very important. So you can expect question from this. Okay. And next is number of EP. Okay. We can calculate in different way also. There is one equation for EP. V plus X plus or minus charge divided by 2. What is EP? EP is number of electron pairs, and V is valence electron for free atom, and X is the number of monovalent atoms surrounded by the central atom. How many atoms are there surrounded with the central atom? And what is charge? Charge means for ions. Okay, we know that cations are there, anions are there, and for some molecules we know that charge is also there. So that is ions. And number of BP. BP charge 2. Okay, number of BP is equal to number of atoms surrounded the central atom. Okay, either you can see XP means number of monovalent atoms surrounded by the central atom. Number of BP means number of atoms surrounded by the central atom. This is monovalent, this is number of atoms. Okay, so I will give you one question that you can do it. So before that guys, this list is very important. You can expect question from this list. Okay, in your NEET exam, if they are asking means only they will ask this species. Okay, only they will ask this species. So if you want, you can do it. Okay, so do it as homework. Okay, so next is a question, you can do the answer. Okay. well. Yeah. So which of the following has geometry different from others? So tell me what is the correct answer. Correct answer கணிச்சதுக்கு அப்புறம் தான் நான் பண்ணுவேன். Tell me what is the correct answer, da. Fourth one is the correct answer. It is different, okay. So then I will give you another question. Yeah, come on. Which of the following has a shape different from others? So when you consider PCl3, so we know that PCl3, lone pair 1, bond pair 3, NH3, bond pair. So we can, I will tell you from first, okay. So if you are considering PCl3, so phosphorus is the central atom, okay. So you can write phosphorus. So what is the atomic number of phosphorus? It is 15. So it contains 5 electrons in the outermost shell. So you can write 5. So you can write how many bond pairs are there? Bond pairs is 3 and lone pair is 1. Okay. So when you consider nitrogen, so nitrogen contain atomic number of nitrogen is 7. So electronic configuration of nitrogen is NH3. So it is nitrogen, outermost shell contain 5 electron. So bond pair is 3, lone pair is 1. So when you consider PH3, so same, so phosphorus, outermost shell contain 5 electron and bond pair is 3 and lone pair is 1. So when you consider BF3, so outermost shell contain 3 electron for boron and bond pair is 3, lone pair is 0. Okay, only 3 electrons are there in outermost shell and that 3 electron is bonded with 3 other fluorine atom. Okay, so there is no lone pair is 0. So correct answer is 4. Okay, correct answer is 4. Then I will give you another question. So this is the question. இது NEET 2020 ஓட question. Okay, NEET 2020 ல வந்து, so yeah, it is NEET 2020 question. Okay, come on. So come on, quick. What is the correct answer? Okay. Any idea? So we can check, okay. So come on, fast. It's very simple, okay. I want answer, otherwise I'm not going to share the answer, okay. So if you are saying the answer, then I will. Just if it is wrong also, just tell me the answer. Yeah. So when you consider XF4, so xenon contain outermost shell, it contain 8 electrons, okay. It is a inert gas, so it contain 8 electrons. So when you consider XeF4, you will get Xe 8 electron, okay, it contain outermost shell 8 electron. So 4, okay, bond pair. So here I am writing bond pair is 4, and what is the lone pair? So how many lone pairs are there? So we know that 2 lone pairs are there, okay. So xenon, that means 8 electron is bonded with, okay, 8. So when you consider 4 bond pairs are there, okay. So 4 fluorine is bonded with 4 electron of xenon, okay. So rest we can see 4 electrons are there, that means non-bonded electrons, 4 non-bonded electrons are there. So when you consider pair ways, so lone pair is 2. So bond pair is 4, lone pair is 2 means, bond pair is 4, lone pair is 2 means 4, 5, 6, this is 5, 6, 5, 6. This is A, this is 1, 2 square planar. Shape is square planar, yes, square planar. So square planar is, so we can eliminate 1 and 2. So next we can consider XeF4. XeF4 means Xe contain 8 electron in the outermost shell. Bond pair is 6 and lone pair is 1. So total 7. 7 means distorted octahedral. Yes, this is distorted octahedral. This is distorted octahedral. So B is 3. This is also correct. Okay. Then next we can say consider XeOF4, okay, xenon. So here you can see. So I'm not drawing properly, not the proper structure. Fluorine is there, fluorine is there, fluorine is there, fluorine is there. So 1, 2, 3, 4, 5, 6. Okay, 6 electron are bonded. So how many lone pair are there? Lone pair here. Bond pair is 1, 2, 3, 4, 5. Bond pair is 5 and lone pair is, when you consider lone pair, 1, 2, 3, 4, 5, 6. 6. So 1 lone pair is there. So 6 means 6 means square pyramidal, no, and not square pyramidal, yes. 6 means yes, pyramidal shape. Correct answer is And then pyramidal, how it will become pyramidal? No, it's not pyramidal. It is square pyramidal only. So, square pyramidal. Correct answer is option 3. Option 3 is the correct answer. Okay. Then what? Valence bond theory. Okay. What is valence bond theory? VBT na solo. Okay. Normally we will say it is VBT. So, what is valence bond theory? What is valence bond theory? So, valence bond theory, so normally Pulling and 𝐓𝐚𝐿 and London. Okay, so 3 scientists is developed by normally 𝐓𝐿 and London and further improved by Pulling. Okay, Pulling, you know Pulling scale and all. So, same Pulling. Okay, so Pulling improved this valence bond theory. So, it is also called orbital concept of bonding. This is very important. Okay, this is also called orbital concept of bonding. So, consider 2 hydrogen atoms. Okay, when you consider hydrogen 2 atoms, okay, we can consider A and B. Okay, so approaching each other having nuclei. So, the Na means nuclei of A and Nb means nuclei of B, and electron present in them are represented by Ea and Eb. So, Ea means electron presented in electron represent this Ea represent the electron of A atom and Eb represent the electron of B atom. Okay, when the 2 atoms are at large distance, okay, 2 atoms are at large distance from each other, there is no interaction. Obviously, there is no interaction between atom when they are in large difference. Okay, so there is no interaction between them. As they 2 atoms approaches each other, new attractive and repulsive force will form. Okay, so if the atoms are approaching each other, okay, 2 atoms are approaching each other means what will happen? You can see there is a repulsive force as well as there is a attractive force will start to will form. Okay, will form. The repulsive force and the attractive force will started to forming. So, here you can see, okay, this is Ha and Hb, Ha and Hb, 2 hydrogen atoms. So, here you can see, so this is the electrons. So, at a particular distance there is no interaction, but it's approaching together means what will happen? Approaching each other means what will happen? There is a attractive force. Okay, there is a attractive force between that 2 atom and as well as there is a repulsive force between that atom. So, here you can see this is the old force. Okay, this is the old force. And here you can see this is the new force. Okay, this is the new force between electron of this A and electron or hydrogen nucleus. Okay, obviously electron is negative charge. Okay, nucleus is positive charge. So, obviously attraction will be there. And electron attraction, when you consider electron are approaching. So, electron is approaching means you can see repulsive force. Okay, you can see repulsive force. So, I hope it's clear. Then next, orbital overlap concept. Okay, what is orbital overlap concept? So, we know that different type of orbitals are there. So, when you consider s orbital is there, p orbital is there, d orbital is there, f orbital is there. So, it will overlap each other. Okay, it will overlap each other. When 2 atoms approaches each other to form a bond, their atomic orbitals overlap. So, when 2 atoms are approaching each other means what will form? So, obviously bonds will form. Yes. So, that bond means atomic orbitals. Okay, atomic orbital overlap. That bonding means atomic orbital overlap. Okay. So, next, the overlap between the atomic orbitals can be positive, negative or 0 depending upon the characteristics of orbital participating in overlap. Okay, so when you consider that overlap, okay, normally what we will consider, two atomic orbitals are coming and they are overlapping. That overlap between atomic orbital can be positive or can be negative or can be what, zero. Okay, that depend upon the characteristics of that orbitals. Okay, so that I will tell you. So when you consider positive overlap, okay, when you consider positive overlap, here you can see it involves the overlap of the lobes of same sign. Hi David, Emmanuel, yes. So positive overlap means it involves overlap of the lobes of same sign. So I will tell you. So here you can see this is when you consider this is your p, okay, this is your p orbital lobe. So one side is positive, another side is negative. So if same side, I will draw here. Okay, if it is positive and positive, okay, it's overlapping together means what will happen? It is positive overlap. Assume that it is positive and it is negative means it is, you can see, okay, it is negative overlap. Okay, positive overlap you can see here, positive, or so S, when you consider S is completely positive only. So S is overlap with positive side of p orbital. Then it is also positive. Negative means opposite sign overlap together, that is negative overlap. Okay, so here you can see positive overlap, same side overlapping, and negative overlap, different side overlapping. And what is zero overlap means? So here you can see zero overlap means out of the phase overlap. Okay, it is actually out of the phase overlap. So to different out of the phase overlap to different orientation direction of approach. Okay, different orientation of direction of approach. Okay, so here you can see this is zero overlap. Okay, positive and negative, there is no overlap. Okay, this is out of the phase overlap, so it is zero overlap. Okay, it is zero overlap. Okay, I hope it's clear. Then we are moving to proper MOT. type of overlapping, okay, type of overlapping and nature of covalent bonds. So we know that covalent bond, it's mainly covalent bond. When you consider, there is a sigma bond and another one is a pi bond, okay. So we know that sigma bond means it is a strong bond, okay, and it is a single bond. So pi bond means it is, if it is double and triple bond, if multi bond is there means double and triple bond, unsaturated bond is there means pi bond is present, okay. So pi covalent bond and sigma covalent bond. So actually single bond is sigma bond and pi bond means that is triple, and the second bond, when you consider, this is the double bond, okay. So how many pi bonds are there in double bond? Only one pi bond is there, okay, one pi bond is there. So when you consider sigma bond, okay, so when you consider triple bond, how many pi and how many sigma bond is there? How many pi and how many sigma bond is there? How many pi and how many sigma bond is there in triple bond? Tell me. How many pi? Yes, very good, David. 1 sigma and 2 pi. Yes, when you consider triple bond, 1 sigma bond is there, 2 pi bond is there. So when you consider single bond, only pi bond is there, okay, only pi bond is there, okay. So this is the concept, okay, this is the concept, okay. So the covalent bond can be classified into two different type or two different category. One is sigma bond, another one is pi bond. So here you can see what is sigma bond, okay. So how sigma bond will form, okay, how sigma bond will form. So here this type of covalent bond is formed by the axial overlapping of half-filled atomic orbitals, okay. So this type of covalent bond is formed by the axial overlapping of half-filled atomic orbitals, okay. So here you can see this type of covalent bond is formed by axial overlapping, and there is two different type of overlapping. Axial overlapping is there and equatorial overlapping is there, okay. So axial overlapping of half-filled atomic orbital, there is no, it's half-filled atomic orbital with the half-filled, okay, half-filled axial atomic overlapping you can see. So when you consider this one, okay, the atomic orbital overlap along the internuclear axis and involve end-to-end or head-on-head overlap. So head-on-head overlap means, so this is a p orbital, okay, this is the p orbital. So when you consider head-on-head overlap, yeah, this is head-on-head overlap, okay, this is the head, okay, this is head-on-head overlap. Normally this is the head-on-head overlap, okay. So if it is head-on-head overlap, we can say sigma bond will form, okay, sigma bond will form, okay. So the atomic orbital overlap along the internuclear axis and involve end-on-end, okay, end-on-end overlap or head-on overlap, okay, head-on overlap, or there is one more overlap, sidewise overlap, okay, this is sidewise overlap. So sidewise overlap and head-on overlap is there. So the electron cloud formed as the result of axial overlap or cylindrically symmetrical about their internuclear axis. So here axial cloud, okay, axial cloud means the electron cloud, okay, you can see axially electron cloud are there. The electron cloud formed as the result of axial overlap is cylindrically symmetrical about internuclear axis. The electron constituting sigma bond are called sigma electron. So suppose, okay, so here you can see if sigma single bond is there means we can say yes, sigma bond, okay. So sigma bond forming electrons are called sigma electrons, okay, sigma bond forming electrons are called sigma electrons. So I hope it's clear, I hope it's clear. So I will give you a 5 minutes break, okay. yes, so guys, I think we can finish the session, and we can, I think almost it's not done, so we can continue this in third part. Okay, we can continue this in third part. So I hope it's clear. If you have any doubt, so you can put the comment. Okay, so thank you so much, students, and bye bye.